Everything you need to know about products and services that can improve your life. This is Experts on Call on CL 650.
Welcome back to the program. I'm Sterling Fox, joined in studio by the president of Interprovincial Roof Consultants, Sean Lang from Cloverdale, BC. Back in the studio with us, Sean. I was looking at an ad, one of those apartment ads they have all over the newspapers these days. But, you know, one of these shiny new condo towers that are either being built or in the process of. And there was another article on the page behind it, and the writer was talking about these super-duper swell-looking condo buildings, the skin, the outer exterior of these buildings nowadays, the writer was saying, has a life expectancy of somewhere between 15 and 20 years before the materials involved in the exterior of these buildings begins to degrade in some way. I'm thinking, wait a second, I just looked at the prices they want for some of these apartments and some of these shiny new buildings, and you mean to tell me this thing might start to sort of unravel 15 or 20 years down the road? If that's the case for the outside of the building, Sean, what's the story on the roof? Is it as likely to begin to degrade in the same period of time?
Well, in some cases, yes. Unfortunately, the construction economy is governed by money, right? And there's a lot of builders that are building buildings. I used the word building too many times in that sentence.
That's all right.
But they're constructing.
I started it.
They're constructing things with the most commodity-based materials that are available that meet building code.
Okay.
So you end up with.
So it's code, but just barely.
Yeah, and so they're getting by on building these structures. And then they make them look really nice with some shiny paint and a couple of different elements.
Oh, they
of design.
look fabulous. There's no doubt about that.
You know, you've got some horizontal siding over here, and then some shingle siding over there, and a touch of rock at the bottom. It looks wonderful. But in reality, is it built very well? Is the quality of the materials very well, very good? And in a lot of cases, it's not. And what's happening is that people are being charged a lot of money for these units.
Oh,
these
sure.
Buildings, these condo, one bedroom for $400,000 or something like that.
Not uncommon.
And it's ridiculous. But this is the environment that we are in, where you know, real estate in British Columbia, and particularly in the Lower Mainland, is very expensive. There's just the ground that you're looking at is very expensive. So now you build a structure on there and you want to sell it, they have to try and find a cost base that's actually sellable. And if they were to build these buildings with the high quality materials and everything was perfect and wonderful, and the best materials you could get, nobody could afford them.
Right.
Because of the real estate market. So it's really buyer beware when it comes down to that. And unfortunately, a lot of people don't know enough about construction that when they go and buy one of these units in these buildings, they aren't watching it being built, or they aren't privy to all the information on how it's being built. And I know when my son bought a unit in a building, I went up on the roof and I had a look around, and I was amazed at the roof that was on there. And it was a flat roof on a building, and it was less than a year old, I think.
Okay.
And it was buckled all over the place because of the type of roof system that was put on there. The material itself was a decent quality from a decent manufacturer, but the method that it was installed to was very poor. And it was loose, basically, on top of the roof deck.
And how on earth could anyone buying into that building have even a sniff of a clue about the quality of construction of the roof? They're walking around, they're looking at the view. Oh, and look at those granite countertops and the refrigerator. It's so nice. Yep. And you know, I mean, hello, the roof is of inferior quality. It was okay quality materials, poorly done.
Yeah. And
they're going to pop for just silly money for this. And so down the road, it's safe to expect problems then with a poorly installed roof.
The interesting thing was we actually had a building inspector inspecting the unit for him, and you know, because there's things about the building I don't know, and we wanted to make sure the building was built at least to an acceptable standard for him to move into. So I took the building inspector up onto the roof and I said, "Tell me what you think of the roof." And he said, "Well, it looks okay."
Right.
And I was like, "You're not concerned about this and you're not concerned about that?" And I was telling him why I'm concerned from a consultant's point of view. And he said, "Well, it meets code. It's a roof system."
Right.
And then, unfortunately, that's the approach that a lot of people have. And that roof system will probably last 15 to 20 years, maybe closer to 15 before it actually starts to, because what's happening is it's a mechanically attached roof system, and it's the membranes will expand and contract, right? pull and tug, and they'll pull and tug on everything. So as it's pulling and tugging, it's causing buckling to happen. And that pulling and tugging is going to, if there's any weak points in the roof system, if the roofer didn't properly bond a seam somewhere, that pulling and tugging, because it's not 100% bonded everywhere, it's only held by individual mechanical fasteners everywhere, screws, it can pull apart these weak points in the roof system.
Oh, okay.
Okay? So it's kind of the weak link in the chain in that scenario where you have a decent product in itself.
Right.
The application isn't the best. It's an acceptable application. It's an acceptable method of installing the roof system, but it's not the best way to do it.
Right.
So, but it's also the cheapest way to do it.
Right. Okay.
So the contractor, when they built the building, went for the cheapest system, the quickest, cheapest, easiest way to put this roof on. Yes, the product is a good product.
And yes, they do meet code.
They do meet code, but it doesn't have the longevity. So what would it have cost them to do a much better system?
Yeah, that's my next question.
Okay,
Thank
well,
you.
if that was a $100,000 roof, it might have cost them $150,000 to do it a different way where it's going to last that much longer.
Okay.
Okay? But from a developer's point of view and the person that's actually putting out the money to pay for the construction of that building, they see that $50,000 difference and they go, oh, no, I'm not doing that. I can buy shinier taps. Right? I can go for the brushed nickel taps instead of just the plain old chrome plated. It'll look so much better on that cheap countertop, right? and that's the way they look at it. So why spend money on the roof when you can spend it on the bells and whistles that are actually going to bring the clients in and make them buy the building?
Can we stay with flat roofs for a little bit here, because it's raining like cats and dogs and will all week, except for the Grey Cup Parade on Saturday, by the way. It's supposed to be sunny, a little window of sunshine on Saturday in time for the Grey Cup Parade, and then back to the wet stuff. So here we are. It's Vancouver, it's November, and it's raining like a son of a gun. And let's stick with flat roofs, because flat roofs accumulate water. And so how much water is permissible or acceptable, I'm trying to even find the right word, okay, on a flat roof before that quantity of accumulated water becomes a real issue?
This is a sticking point with a lot of people in our industry and a lot of people in construction in general, a lot of architects and designers. They have different views on acceptable water levels on a flat roof system.
Okay.
And you have to understand that a flat roof system is built, some are built dead flat, absolutely dead flat. There is no slope on the roof whatsoever.
Right. Some
are built with a very small slope, a very gradual slope towards the drains. Some are built with a little bit steeper of a slope that you actually can perceive when you're walking. You can actually see it rolling around on the roof system. Each one costs you more money.
Okay.
So
the flattest being the cheapest?
The flattest being the cheapest.
Gotcha.
Okay. If you have a flat structure and you're going to put a membrane on it, which is basically a skin that holds the water, so that's going to be very cheap to install. Now, you could build that structure with a slope on it. It's going to cost you a little bit more in the framework. The carpenters are going to have to spend more time making sure the slope is followed and everything meets up. There's more to construct that kind of thing.
Right.
That'll provide you a slope to drain, and the water will be able to run to the drain better. The other option is to build a flat structure, absolutely flat structure, and then to put sloped insulation underneath the roof membrane to create the slope to drive water towards the drains.
Gotcha.
It costs you more money. So here we go back to the previous comments about builders wanting to spend the money, and sometimes they won't put that slope in. Now, how much water is an acceptable amount on a roof system?
Okay.
How do we look at that? You could look at the structural load of the building. What is the design load of that structure? And I'm not a structural engineer, so I'm not going to get into any numbers or any particulars on this, but if a structural engineer says that the roof system can hold a certain amount of weight, which it has to, because there's going to be snow loads, and that sort of thing, then that would be the maximum that the roof system should be able to have on it as far as water or snow. Now, as far as the membrane is concerned and the quality of the membrane and the longevity of the membrane and the effect of water sitting on the roof, that's another story, because there's different things that can happen to a roof system when water sits on it. With most of the membranes that are out there now, not like the old tar and gravel systems, which were an organic core membrane, meaning it had wood fibers in it.
Okay.
Those systems, if they had pooling water on it, that water could, the hydrostatic pressure of the water could force itself down into a weakening system. As the system gets older and the oils that are in the membrane start to evaporate and exposes more of the wood fiber core, the water can press itself in. I used to call it soaking, where the water soaks into the membrane and actually starts to further deteriorate the membrane and ends up splitting. It's weaker with the tugging and pulling we were talking about earlier. It rips apart, and you have a tar and gravel roof that splits everywhere.
Right,
and
but nowadays we're away. We've gotten away from the tar and gravel as the primary roof type.
Yeah, now we have there's rubber roof systems. There is SPS roof systems.
Sorry, all of these. I'm sorry to keep interrupting, but I don't know much about roofing, Sean, and neither does many people listening to us. And don't pretend to the other way. I know you don't. But these membranes, is it some kind of polyvinyl? Talk to us about the composition of these membranes. It's a skin that you put over top of the roof.
Basically, there's different kinds, and they come in rolls typically, and different widths of rolls, and they're bonded together to form basically a monolithic layer once it's all done. Okay. Because the welds shouldn't come apart if they're welded properly. So in the case of an SPS roof system, which is actually a torch-on roof system, is a more common term, the rolls are 1 meter wide, and they're bonded together by heating them with a torch, welded together, so that at the end of it, you actually have a monolithic system. It's one big skin that sits on top of the
all of these 1 meter wide strips bonded together with heat.
Yeah, that's where the art of it is bonding them together properly to get a full bond everywhere.
Okay.
So that membrane is actually usable in ground level waterproofing, in planters. It can be put underwater without deteriorating.
So, but based on that, then I can assume that some water accumulation on one of these newer membranes is okay. It's not perhaps as potentially dangerous as the same amount of water on the old tar and gravel roof.
No, it's not. And that's the thing that people have to understand is you have a non-organic roof system now. Even if you're going to rubber, you're going to TPO or SBS, it's a non-organic system, so there's nothing can rot in that system.
Okay.
So now you have to look at aside from weight load problems, let's take that out of the equation. So now you have what I like to call 3 levels of water accumulation, which is puddling, you have ponding, and then you have pooling. And a lot of people simply refer to water on a roof as ponding. They just call everything ponding. If you have a 2-foot wide puddle of water, they call it a pond.
They call it a pond.
If you had the whole roof flooded, you call that a pond, which is kind of wrong.
So you're after more accurately descriptive adjectives.
Yeah, I would prefer to say that, and I've kind of come up with my own little standard where an accumulation of water that's under a 1/2 inch deep and less than 10 feet by 10 feet in area would be considered a puddle.
That's a puddle.
And you might have several of those over a roof, which will evaporate in a period of time, and they're gone. Not a big deal. There's no significant weight load. It's not going to be a big issue. When you get above a 1/2 inch deep, but still if you go wider than 10 by 10 in area, but a 1/2 inch deep, that would be a pond. A pond.
Oh, okay.
So it's not deep, but it's vast.
There's plenty of it.
Yeah.
Okay.
So, but again, we're not dealing with a lot of weight load because it's spread out over a large area. And when you're talking about pooling, you're talking about over 1 inch deep and over 10 by 10 area.
And that sounds dangerous.
Now you're getting into a weight load issue potentially, and an amount of water that might take a long time to disperse or evaporate. So that would be a more significant issue. So when I go up on a roof system and I see what I call a puddle on the roof, I don't get very concerned.
Right.
Now, if the roof system is weak, poorly applied, that's different, because if you have seams in the roof system that could be compromised by water getting in there,
it doesn't matter how much, is it? It
doesn't really matter how much, how deep the water is. That water is going to go in there, and that's a concern.
Right.
The other thing that can happen with water is accumulation of debris, because water will obviously catch debris that comes down from either birds dropping it or leaves falling, and as the water recedes, that debris kind of gets pulled along the roof with it. And a situation occurs which is called mud cracking, where as the debris dries on the roof system, it kind of condenses a little bit and can pull on the granules. And actually can damage the granule surface a little bit. So that is a bit of a concern when you're talking about water on a roof system. And that's probably one of the only real detrimental effects of the water on the roof system.
Is it smart, by the way, from a maintenance point of view, and I don't live in a big condo or apartment building, but do building managers and personnel go up on these big flat roofs? And if there are bits of debris or pools or ponds or puddles of water, remove them with vacuum cleaners or, those HVAC things. Is there a maintenance program on these big flat roofs in most cases, or do
No.
people just wait until something goes horribly wrong?
Yeah, most people don't do anything. I have seen pumps on roofs before, though, where somebody who cares about the roof system will go up and put a sump pump on the roof,
Okay.
and they'll actually pump the water off because they're concerned about the weight load on the building.
Right.
And if the building's not built to structurally handle the load of the water, then it can be a concern. And if there's any weak structural members in the building, over time the excessive weight load can cause further increase of the weight load as the structure weakens further and further and the deck sumps and that kind of thing.
Right.
So there's a lot of concerns when it comes to the structural load.
Right. And you mentioned snow, again, is obviously the maximum weight load that engineers worry about. Now, fortunately, we had a little bit of a cold snap back there a week or two ago, but now we're just back to the moist, wet stuff that Vancouver's so famous for in November. But when we come back, we'll talk a little bit about snow. And winter's far from over. And our guest, is the president of Interprovincial Roof Consultants and knows a bit about snow and extreme Canadian winters. Sean Lang in studio. This is Experts on Call on CIL 650, and we'll be right back.
There's still more ahead with Experts on Call on CIL 650.